Before you can name compounds, you need to keep straight the rules that you need to know for each type of compound. So first thing, at the beginning, I would ask whether this compound has metal present. Is there metal? If the answer is, let's say, metal in the first element, okay? If the answer is no, right away I know I'm dealing with molecular or covalent compound, because covalent is made up with non-metal. So once you figure that out, you know you have to use prefixes. You do have to memorize 1 through 10, okay? So let's go over a few, just first 3, but the rest should be provided in the PowerPoint. Mono, di, and tri, and tetra for 4, but that information is given to you. So right away, okay, if it's non-metal, you're dealing with a covalent compound or a molecular compound, same thing. I have to use those prefixes, and that's it, okay? So that's on one side. If there's a metal present for the first element, yes, then you know you're dealing with ionic compound. With ionic compound, it's not as straightforward as covalent, because you have to look at what group does the metal belong to. For example, group 1 and group 2 metals, they're going to always have a charge +1 and +2. So that means no Roman numeral. Okay, so group 1 and 2 is you just name the metal, and then second with the IDE if it's anion comes from periodic table, or if it's a polyatomic ion, then you need to look up the polyatomic ion, the name of polyatomic ion name. All right, so no Roman numeral for group 1 and 2, but there are a few exceptions that you need to know that are not in group 1 and 2, but they always have the same charge, so you will not need Roman numeral for these metal ions, okay? They are silver. Silver is going to always have a +1 charge. Cadmium, always +2. Zinc, always +2. And aluminum, always +3. So even though some of these are in the transition metal, you do not need to use Roman numeral to indicate their charges, because they're going to always stay the same. So what if it's an ionic compound and you're dealing with the transition metals? Then what you have to do is you need to figure out the charges and indicate them in the Roman numeral. For example, if you want to say iron 3 chloride, you need to write iron 3, Roman numeral 3, chloride. If you do not indicate the Roman numeral, which represent the charge of transition metal, then you're not going to know what the charge is, okay? Because then you're not going to be able to write the chemical formula. So if I give you iron Roman numeral 3 chloride, you know that iron has +3, chloride has -1. When I sum those two charges, it doesn't equal to 0, so I know I need 3 chloride. Then it's going to be -3, giving you FeCl3 as a formula for iron 3 chloride. But imagine if I just give you iron chloride. How would you know what the charge of iron is? In that case, I'm not going to be able to write the chemical formula. Okay, so this is kind of the overview of naming compound. There's a detailed video on this flow chart, but now what I want to do is I want to just go over questions. Okay, let's just do some problems. So here they are. Write the chemical formula for each of the following compound. First one is sulfur tetrafluoride. Looks like it's going to be covalent. I see tetra. That tells me right away, okay, they are using prefixes. So that should be pretty easy. Sulfur is S. Tetra means 4, and the anion, or actually, sorry, it shouldn't be anion in this case. Non-metal is going to be fluoride. So it's going to be SF4. Manganese, Roman numeral 2, acetate. So this is a transition metal. So go ahead and write out the charges. I'm going to do some side work here. And the Roman numeral tells you what the charge is. And acetate, you either have to memorize that or look up the polyatomic ion. And what for the introductory chemistry class, what I recommend is you look at the polyatomic ions chart and don't memorize what's on there, but be familiar with it. So you know what are some of the polyatomic ions. If you're taking Chem 1 class, you do need to memorize that, okay? So acetate, if you look it up, you're gonna see CH3, COO minus, or you're gonna see C2H3O2. Either one is correct. I prefer one on the bottom, but you can use one or the other, okay? They're the same thing. Looks like they both have negative, acetate has -1 charge, manganese is 2, so that means I need 2 of these to balance the charges out. So the chemical formula for this one is going to be Mn parenthesis CH3COO2, or you can write as Mn C2H3O2, and you need 2 of those. Let's do the next one, potassium phosphide. Potassium is in group 1. Notice there is no Roman numeral for that because we should know potassium is +1. And phosphide looks like comes from phosphorus, so that's going to be P, and the charge of group 15 is going to be -3 or 3 negative. Okay, so again, you do need to sum them and make them equal to 0. This is not, so you need 3 of this potassium ion to balance that out. So the chemical formula becomes K3P. Dinitrogen pentoxide. All right, so this is covalent. Di means 2, so it looks like 2 nitrogen. Penta means 5, and notice there is A usually, but when you have like 2 vowels, they drop the A. So that's going to be oxide, so that's oxygen. Penta means 5, so that's going to be the formula. Silver chloride. Notice silver is transition metal, but they don't indicate the charge in Roman numeral because we need to know the charge of silver. It's one of the exceptions I ask you to remember. Silver is +1. Chloride is group 17, -1. So this one, +1 negative, is 0 already, so I can just write out AgCl. Aluminum dichromate. We need to be careful with this. First of all, I mean, you should know this is ionic because we are dealing with metal here. But I don't want you to get all caught up because you see that has to be covalent. The answer is no. Dichromate is one of the polyatomic ion. So that's why I want you to kind of look at the chart and see what they have in there so you can remember. All right, so aluminum is going to be metal, so that's +3. Dichromate, when you look it up, it's Cr2O7, and the charge is -2. So that's going to be not balancing out, so that I need 2 of aluminum to make it +6, and I need 3 of dichromate to make it -6. Remember, when you have a polyatomic ion, you have to treat the whole thing as a unit, 1 unit. So don't get confused by the 7 after oxygen. It's one thing. Each whole thing has a charge of -2. You need 3 of them to make it -6. You need 2 of aluminum to make it +6. Okay, then this cancels out. So that's going to give you Al2 Cr2O7 3. Cobalt 3 oxide. Cobalt is a transition metal, so they give us the charge in Roman numeral, so that should be easy. And when you're writing cobalt, please make sure the O is the lowercase, not big case, because then it looks like carbon monoxide, okay? So make sure the lowercase, and then Roman numeral tells you the charge, so I wrote +3, and then oxide, it should be -2. +3, -2 doesn't summit equal to 0, so I need 2 here, 3 here. So cobalt 3 oxide is going to be written as CO2O3. Magnesium perchlorate. Okay, so let's write it out. Magnesium, I know it's going to be group 2. Perchlorate looks like polyatomic ion. So per means the highest number of oxygen, so it should be ClO4 minus. Again, it doesn't balance out, so I need 2 of the perchlorate to make it -2. So it's going to be Mg parenthesis ClO4 2. Tin 2 nitride. Okay, so another transition metal tells me the charge is +2. Nitride should be coming from nitrogen, and it's group 15. Charge is -3. So it doesn't balance out, so I need 3 of the tin and 2 of the nitrogen to make it +6 and -6. The formula becomes SN3 and 2. Okay, last one is carbonic acid. With acid, right away, I know I have to start with hydrogen ion, which is H+. And this part is where you have to kind of think about. It's end with an ic, which I know that means it's 8. And because it doesn't start with hydro, I know that this anion comes from polyatomic ion. So look at the polyatomic ion chart and see which one says carbonate. That is CO3, 2 negative. So +1, -2 doesn't balance out. You need 2 hydrogen to make it +2 here. So carbonic acid should be H2CO3. And just to be technical, usually acid is in aqueous solution, so I'm going to go ahead and put AQ in there. Let's do a few more problems. Write the name for each of the following compounds, okay? So first one is looks like lithium oxide. This one is going to be cadmium cyanide. Now cadmium is one of the transition metals, but this is one of the exceptions. So you do not need to put a Roman numeral for this. We should know that's +2. And the anion portion is the polyatomic ion. It's a cyanide. So you just write the name for that. So remember, polyatomic ion, you don't have to worry about dropping the ending or anything. You just need to either memorize them or look them up and write down the name that is on there. Okay, the next one looks like sulfur. Trioxide. Sulfur is not metal, oxygen is not metal. Remember with covalent, you use prefixes. But one thing I wanted to go over is when the first element is just 1, you do not need to add mono. Okay, so that's why I just write sulfur trioxide. Next one looks like have AQ and start with H, which means it's probably it's going to be what? Acid. So it's going to be something acid. Because this one is acetate, and that's in the polyatomic ion, I know I have to call it acetic acid. You drop the ending, ate is going to be ic, ide is going to be us. Okay, so acetic acid. I2O4, Well, that's going to be covalent, so I need to use prefixes. So 2 iodine, so di-iodine. And 4 oxygen, so that's going to be tetra oxide. But when you have A and O, you always drop A there, okay? Next one is going to be lead. And I know right away lead is transition metal. It's not one of the exceptions. So then I'm just going to go ahead and put a parenthesis because I do need to indicate the charge of lead. So I'm going to do that in a minute. And then look here. We have anion as acetate. That's a polyatomic ion, so you just look it up. So to figure out the charge of lead, I need to know what the charge of acetate is. And I know that's going to be -1. So it looks like you have 4 acetate, which tells you the overall net charge of negative is -4. -1 times 4 gives you -4. And looks like in the formula you only have 1 lead, so then I know that lead have to be +4 to balance that out. So the Roman numeral is going to be that, lead for acetate. This one looks like an acid, okay? AQ start with H. And because the Cl comes from periodic table, I know it's going to be hydroic acid. Something ic acid. Well, because this is chlorine, we're going to say chloric acid. So notice when you're naming acid, you're going to always see hydro if the anion comes from periodic table. If the acid name is just something ic acid or us acid, you know that anion comes from polyatomic ion. All right, the next one is going to be copper sulfate. But I'm going to go ahead, again, because it's a transition metal, I'm just going to go ahead and put a Roman numeral. I'm going to figure that out in a minute. So to do that, I need to know what the charge of sulfate is. So look it up. -2. You have only one of that, one of copper. So copper has to be +2. Next one is going to be iron something. Again, it's a transition metal, so I need to put a Roman numeral. And the second one is chloride. So to figure out the charge of iron, I need to look at the anion part. Cl has charge of -1. You have 3 of those. So iron has to be 3 to balance the charges out. Next one is going to be tin something. Again, tin is a transition metal, not one of the exceptions, and is nitride. Comes from nitrogen. So we know that nitrogen is going to be -3. And looks like you have 4 of those, so that's going to give you -12. Again, that means I need +12 on this side. But you have 3 10, so that looks like you need +4 times 3 give you +12. So it looks like 10 is Roman numeral 4.